to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, and you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, my name is Adam Sandman. I live in Washington, D.C. in the United States, although I'm originally from Great Britain. I work for a software testing company called Inflectra. And in my speech, I'm going to be talking about web testing. Why is web testing so hard? And how can we use artificial intelligence to make web testing easier? Come to my talk and find out how. See you then. Welcome. And if you are now joining the Testing the Moz500 Top Websites, AI Can Help by myself, Adam. Welcome to TestCon Europe. I'm coming to you live from the Washington, D.C. area, though you can probably tell from my voice that I'm actually originally from Great Britain, although my family actually comes originally from Lithuania. So it's interesting to be presenting here like a return back to the family home. So I appreciate the opportunity. This is a little bit about me, which is the least important thing today. If you want to get hold of me, though, you can find me on Twitter, LinkedIn, email, and various other places. And I do speak at various events. And so I appreciate TestCon having me speak today. And today we'll be talking about test automation of websites specifically. And the idea really is to talk about why are testing of websites and web applications so difficult? Is it harder than other kinds of applications, and what can we do about it? And then we're going to look at some things we found using a research project using some deep learning algorithms to try and figure out what makes web testing so difficult, especially when we're in the real world with the applications that we have to test every day. A lot of vendors, probably including ours, will show you a nice automation tool that will work beautifully against a simple application that has a login page and does a few simple things. But as soon as you have full contact with a real application, it breaks down quickly. So this was a project to try and figure out how we can make that better. I've got some tips and tricks for how you can improve your testing, and then I'll take questions at the end. So first of all, as I just alluded to, it really began with a question. Why is test automation so difficult and unreliable? And this is because we do a lot of demos. We meet with a lot of clients who are looking to do test automation. And in some cases, they're doing test automation for the first time. Other times they are experienced. But in every case, test automation seems to be much more difficult and expensive and harder than they anticipated. And so we decided it would make sense to do a little bit of research to figure out what's going on. Why is it so hard? Are there some unique aspects to make automated testing of web applications difficult? Because we have clients with different experience levels and they all seem to struggle. So that told us there was something deeper going on here. It's not just a skill deficit or a tool issue. There's more things going on. And so what we decided to do was research the top 500 websites in the world. And this list is called the Moz Top 500, which is where we get the name of this talk. So if you're involved in any kind of digital marketing, you're probably very familiar with this. The Moz 500 is basically a ranking by most visits of websites in the world. And it's used when you're doing search engine optimization. Moz is actually an SEO tool. And Moz will let you figure out which are the most valuable websites so that you can get the links from these websites to improve your search rankings. That's the purpose of Moz and Moz500. The higher up on the list you are, the more popular you are, the more people will want to have you link to them. But we decided that it actually was a good proxy because we felt like if these are the websites that are the most popular, Google does a good job of indexing websites and it ranks them by a variety of factors, but it does look at the composition of the web page, how good they are they constructed well. So this should be the gold standard. So we looked at these 500 unique websites and we began to do a project on them to see how easy would they be to automate. Because if these applications are easy to automate, then we should have no problems with some of our internal applications, or at the very least, it would let us rank our internal applications against these websites. It's a good benchmark. If, on the other hand, these websites are also difficult to automate, then that tells us there's a more systemic problem going on here. And before I jump through a little bit further, just to talk a bit more about why we got to this question, it actually came about because we saw a lot of clients doing demos trying to do automation and just really struggling. So it was really to try and figure out what was the root cause of their troubles. So what did we find? Well, we found that a lot of the things that you're supposed to assume when you're doing automation are not the case. So again, these are the 500 websites built by large companies like Facebook, like Google, Amazon, and a variety of others. And the list again is here. This is the list when this was done. This list changes all the time. Go to moz.com. You can find the list. So these are websites that should have large teams who know what they're doing, who are experienced in web design, experienced in web applications. They're using the latest frameworks like Angular and React. So these are the kinds of websites you're going to be coming across, or applications that are a lot like them. But what we found was, first of all, even for these well-crafted applications, IDs were not unique. IDs are meant to be unique on a page as a W3C standard, not so much. So anything that's using, locators or any kind of automation, XPath or CSS to find an element based on an ID is going to quickly run into problems because they're not unique. So that's the first problem. The other thing we found is when we analyze these sites over time, when you look at a page once, you get a sense of what's on the page. You look at IDs, you look at things, they might sound like they might be valuable. They might be useful things you can use for automation. So for example, you might have a header or a footer, a contact us bar that you can see here. These things might look good. Other ones on the right, dynamic IDs, which is numbers. As an automation engineer, you don't want to try and lock onto these to automate. They're going to change. But there might be ones in the middle where you think, well, is that an ID that's valuable? Is it the ID of something like this CU card group media 194? Is that something useful that we can automate? Or is it something that's going to change every time the page loads? When you look at a web page once, you've no idea. In our deep learning analysis, what we did is we snapshotted these websites over a period of 2 or 3 months so we could see how do they change. We found there's a lot of semi-dynamic IDs. So every time you go to a certain page, it might be different. And sometimes it's different because it's a different item. Sometimes it's different because the page loaded the second time. And it's not obvious which is which. So a lot of times when you're trying to compose an application and automate it, you don't know, as a human looking at the web page, trying to do automation, what's dynamic, what's static. It becomes very difficult quickly, especially once you get beyond simple login pages or header bars or nav bars, things where it's more obvious that it's going to be the same every time. So that was another major problem we found. Not a very clear distinguishing between dynamic things and static things. Another thing we found was that we would hope that there could be some attributes that will be useful, because if IDs aren't unique and they're hard to use, maybe there's some other attributes. Maybe there's some ARIA attributes. ARIA is an accessibility standard. You're supposed to be doing that. If you're building an application, you're supposed to be using alt text. You're supposed to have roles. You're supposed to have titles. It's actually required to be accessible to people who don't have eyesight or have other disabilities. Many countries require it. But that doesn't mean it's being used. And therefore, when we looked at it, very, very, very few websites use the same set of attributes. By far and large, the only attributes we saw consistently being used were classes and hrefs. And in fact, even IDs are being used less because a lot of tools like React and Angular don't actually even add IDs anymore. If you use a React framework, if you've ever used it as a developer, it doesn't automatically generate IDs for a lot of things. It's all managed internally in the state. Well, that's great for developers, but it makes automated testing really difficult because the only attributes that we found that were common were the class attributes and the hrefs. Okay, so that's a problem too. And for example, this was an application we looked at. So we looked at some other applications as well as the Moz500 to compare. We looked at some business applications that our clients are using. This is Microsoft Dynamics Business Central, which is a very common ERP and CRM tool that's being used. It's cloud-based. And as you can see here, there is some use of things like ARIA label and title, so that's quite good. So as an automation engineer, you've got some attributes like label and title which are logical, which might give you some information that would be repeatable and usable. By far and large, from an automation standpoint, the only attribute that seemed to be used in any large way was class, and class is a style. It's just showing you how something looks. And as an automation engineer and doing test automation, you ideally don't want to be tying yourself to how the application looks, because that's the one thing that's most likely going to change. So that's a problem also, because the title attribute is only present in 0.05 of cases. The other thing we found was that, okay, so IDs are bad. Okay, that's a problem. We don't have many other attributes. Many frameworks aren't giving you IDs anymore. So what we have left are classes. So classes are good. Classes are least for work. Well, that's not so good either. Look at these classes. This is from an application. I think this is Microsoft Dynamics Business Central again. And you can see right here, there's hundreds of classes, all with these random alphabetic names. They're all randomly generated. So the dynamic classes. So even the style attributes that are being used everywhere, they're meaningless. They're basically almost like random numbers. They're just random letters. And a lot of frameworks are now doing this as well. So that also makes it very difficult. So from an automation standpoint, it's getting actually more difficult. So if we take a step back, why are web applications hard to test? It's because you have the freedom to put anything you like into the attributes. If you're building an application on a mobile application for a native app, or a desktop app on Windows or Mac, for example, you're using a tool to build the application. It's going to enforce certain standards in the way that the controls are laid out. It's going to enforce that you have labels for things. When you're using HTML, because you're coding it effectively in text, and it's up to each developer, there's a huge variety, and there's no enforcement that you have to put in standards like alternative text, like titles for things, like IDs and meaningful labels. So in fact, as we've gone from things like desktop apps to mobile apps, we've taken a huge step backward. As we've gone from basically standard static HTML to the React, Angular, powerful web frameworks, we've taken a step back from automation because we're making the actual generated HTML less meaningful. So, and as you can see we can see it right here. It's very difficult to find anything, to be able to lack onto things. Well, okay, there's even more problems we found. We found looking at some of these applications, you have hidden layers. So for example, when you click on a menu and it pops up a menu, and you close the menu, and you open the menu a second time, you might think that the menu is going to be destroyed and recreated. No. The old menu is still there, but it's now hidden. It isn't even hidden. It's actually just behind the other menu. It leaves it lying around, but just puts the Z index, which is the stacking order. So we have items with the exact same, with the same ID and the same class. The only difference is it's 4 layers above another one. So from an automation standpoint, you think you're recording clicks and actions on the menu that you see that as the user. You're clicking on the menu that the user saw maybe 2 minutes ago when they were actually recording the test. So that's another huge problem we're seeing. Web frameworks are doing this automatically, and your developers may not even be aware this is happening. So this is another example from Salesforce, where as you can see, this part of the tree at the top is in light blue. That means it's all hidden. The dark blue means it's visible. We've actually got the exact same IDs, the exact same elements, but they just hide it. They set the visibility to hidden. They set the visibility to visible. But apart from that, it's identical. And if you don't know that, and you're searching for IDs or classes or CSS, doing Selenium, and you try and find these items, you think you're getting this bottom one that's visible, you're getting this top one that's hidden. And so instead of getting one match, you're getting 2 matches, but your automation code doesn't expect that. Your automation code is going to find the wrong element. And as soon as you start to get tests that are flaky, as soon as your automation isn't reliable, your users are going to, well, your test managers are going to doubt the value of it, and they're going to throw it away, and you build another automation framework and you start again. And we see this repeatedly. People do automation, it starts to work, you see value, then you start to see tests failing when you don't understand why, or tests passing when the application is broken. Because of these kinds of things, they're flaky tests, and very suddenly the confidence in the automation is reduced, and you go back to manual testing, and then the whole value of that framework is gone. So it's really, really important that whatever you automate is reliable and repeatable and fast, because if you don't have those aspects, the automation is going to be discarded. So that's the problem. It's quite a big problem. And as I said, we found this to be unique for web. When we looked at clients doing mobile testing has some challenges in terms of the environment, hooking up the devices, connecting the security, the app store, side loading. A lot of physical, environmental infrastructure things are harder with mobile. But when you actually go to the apps, the controls are simple. Xcode and the Android Studio force you to build the apps in a certain way. There's metadata, and automation frameworks can actually find things relatively reliably. We go back a generation to client-server, Windows apps, Mac apps, desktop apps, basically, and there's reliable technologies for that. And people were used to putting in labels and metadata so that people could use them on screen readers for people who are disabled. And so we were able, as automation engineers, to be able to access that information and reliably find things. So we've taken a huge step back. Okay, that's enough of the problem. Let's go on to solution. So the first thing you can do as a test automation engineer and a test manager, hopefully working with you, is ask your developers, can you do things to make this easier? And I think in the previous talk you will have heard someone saying, well, how do you talk to developers and make them do what you want? That's always hard. Developers are often working under tight timeframes to release valuable functionality, to build business value, release user stories. They feel like this is not their core job. Of course, if the application can't be tested and can't go live into production, then the job isn't done. And with DevOps, you have the advantage now that you're no longer measuring, with Agile, you are measuring how quickly a user story could be integrated into CI. With DevOps, you're now looking at how quickly can a user story be delivered to a customer in production. So the good thing is, I think the metrics of everyone from a development and testing, integrated DevOps Agile team is more aligned, because if the code is written but it can't be put into production because it can't be tested, then the developers and the testers and the whole team are going to lose out. So I think there's more incentives now to work together. So that's one good thing. I would say one key thing to do is have you working with your developers, and for example, if they don't believe there's a problem, maybe have them do your job for half a day. Give them a coffee, buy them pizza, and say, or if we're working virtually, send them virtual coffee, have them go on Zoom, and basically have them try and automate one screen using your framework. They'll see quickly there's a lot of problems, and maybe they could do things to help. They could add IDs, they could add labels, they could add metadata, they could add classes. Now, when you're using tools like React, that can be difficult because the React is building the web page dynamically. You don't really write the HTML yourself. The framework builds it. But you can still add IDs. You can still extend React with plugins to do some of this automatically. So there are some accessibility extensions for React and for Angular and other frameworks where it will automatically generate some meaningful IDs. If not, there are ways you as a developer can add code, extra code to make the system more testable. And if you're not doing it because of automation, you should be doing it because it's really the law in many countries for accessibility anyway. And the good thing is, if it's more accessible to someone who's disabled, it's also more accessible to an automated testing tool. So it's a double benefit. Helps your users and it helps your testers. So it's really a good thing. Now, the one problem will be there are sometimes applications like, for example, Dynamics, Salesforce, various cloud apps that you didn't write. You might be testing an add-on for Dynamics that your company wrote, but you don't control the whole framework. You might be building an add-on for another tool, for example, like a Salesforce extension or a Salesforce plugin. Well, you can test your part, but Salesforce itself is outside of your control. So that's another problem. You may not have control of the whole stack, and even if your developers are willing to work with you, you don't control Microsoft or Salesforce or Oracle or any of the big companies that are releasing functionality. So you might be limited. So what do you do when you can't change the code? Which is a great question, because you can't always. Well, here's some ideas we'll talk about that you can do manually, and then I'm going to talk about some machine ideas that we've been working on. So first of all, from a manual standpoint, let's say you have dynamic IDs like this. You've got a button where it's got IDs. It's got and it's got like this 89 EF7. It's completely meaningless. It probably is going to change. You might get this other thing where you have a dynamic ID attached to something that might be static, like an invoice and a button, just like that. So what you can do is use a combination of ID, class, and role if they have them. You could definitely avoid things like the full, if you're using XPath rather than CSS, avoid the full XPath, because every time you use these intermediate levels, you're making your code less resistant to change, because you really care about this button that you have to click on. You don't care if that button is in the body. You don't care if that body is in 5 divs that make up, the navigation or make up the layout, because the layout may change. Maybe it changes on different screen widths. You don't necessarily want that. What you want is the button. So avoid using things that unnecessarily complicate the XPath or the CSS. Some things we have found can be quite good are indexes. If you're finding a menu and you want the first element, then use the role. But I have to say, if you take nothing away from my entire talk, nothing at all, this is the last bullet, is the one that everyone has told me is the most useful thing to think about. Use the text. Because if you go back to this, there's a button you want to click on. In many cases, the user is going to know what to click on because the user has to see it. And the user will know, I need to click on the menu that says invoices, the menu that says quotes. And maybe that order changes because if I have a different permission, the menu may be different. So the index may not be a good idea. But I know for sure that the option menu is called option, and I know for sure that the text I have to work on is login. Obviously, that means if you're using a localized application, you will have to make your tests run in one language or have different versions of your test. That's the one downside of using text. So if you have got good labels, if you have got like roles or titles, alt text, use those. If you've got URLs that are going to be good, use those. Avoid IDs that have numbers in them. Avoid classes that have numbers in them, but otherwise consider using them. But definitely don't overlook the power of text. It is the most overlooked part of the web page. The other thing would be, don't rely on one locator, because the thing is, if the applications are going to change, and maybe they'll change unpredictably because you don't have the ability to scan this application hundreds of times, try and look at different XPaths and use a combination. So you could use, in this example, we're looking for the text called modules because we know the text is good. We know the title is called modules. That's pretty good. But we're also looking for a role called group. So if the modules label appears in multiple places, we only want the one in the group. So we could use a combination of that. Use this one here, group and title. Use group and title and text. Use a combination of different attributes. Sometimes text is best, sometimes the others are better, or use a combination. So if you have things repeat, you've got less, the system will be more reliable even if it changes. It's so easy to go in the browser, hit F12, copy the CSS that you see, put it into your CLNM code, and you're done. Move on to the next page or the next button. But think much more about this. What's going to change? Choose something that's going to be reliable so you don't have to keep rewriting your tests every week. Another thing would be avoid, as I mentioned, chained attributes. Avoid things like this where you've got lots and lots and lots of divs and things. Instead, try and find the important parts like the role. Use the double slash if it's XPath, and same CSS, same thing. Avoid direct descendants. The browser will often give you bad XPath or bad CSS because that's what it will generate. And so you need to find things where you can avoid attributes that aren't useful. Now, the other thing I mentioned earlier on was hidden layers. How do we deal with these? So I've got 4 indexes, 4 menus. They're identical, and they're all visible. They're all in the DOM tree. If I try and look for an ID or a class, I'm going to get 4 results. What do I do? So use something like this where you always find the last position. And if you could have your framework automatically always add that. That might be a really good idea, because that way you never have to worry about this. As an automation engineer, have your code, scan the application, and if this is something that's persistently a problem, just simply have your automation framework always add this and position last. Now you're always going to find the top layer. You can't fix the application, but you can fix your test. So that's a really good way to actually make things better. And we found this out by doing this deep learning approach across, again, 3 months of data, 500 websites. By doing the analysis, we found this was a common problem. So that's what you could do as a tester writing your tests, you can, just to recap, you can change your tests to have better use of attributes, to have different layer checks. Check for layer height. Is it the top layer, the bottom layer? Pretty much you always want the top. You can also do the same thing with visibility. For example, always make sure that the attribute is visible. Avoid things that are visibility equals hidden. Avoid things where display is none. There's lots of hidden tricks like that. Don't assume that your element is visible. It may be in the DOM. The user can't see it. The test can see it. If you click on it, the test will pass, but it shouldn't. It should fail, possibly, or the reverse. So those are some of the things that you can do. Use text, use different elements. Don't just rely on what the browser told you when you went to F12. Make sure you actually are thinking about how is this page going to evolve, what changes are likely, what's going to break next time I run this test, the next time we do a CI build. So vendors, and I think vendors could be a commercial vendor like us. It could be an open source framework. It could be someone who's building a framework that's in the open source community. What can we do? What can the industry do to make this better? So first of all, we need tools. And when we think of automation tools, we're thinking about automation frameworks. But I think tools could be a different set of things. Tools to help us understand the data. So using AI machine learning, we can have tools that not only look at a web page and say, here's my web page. Well, the tool can actually start to look at the web page every time you play the test, every time it's run, and analyze the website over time. Big data and machine learning is not about looking at a web page and saying, oh, here's my web page. It's about looking at the web page as it's interacted with over maybe days and weeks and months. And as the page is reloaded and as users interact with it, the application can start to understand patterns in that website. And every web application is different. So what it's going to understand from one application will create sets of patterns will be different to another application. So it's really important to understand that when I talk about machine learning and a framework, just because you have an automation framework that's detecting and understanding, say, Salesforce, you could spend months analyzing Salesforce and really understanding how it changes, what its page structure is, what the attributes work like, how the classes work. Machines can do this really well. However, you can't take what we've learned and say, let's try that with a different tool like Microsoft Dynamics or Google or Facebook. It's just not going to work because everyone is different. So the machine learning creates a model, but that model is unique to the application. And also, the model will learn based on the application and get more insights. But at some point, if there's a massive update of Google and they completely change their framework, or if you get your application that's written in React and you migrate it to Angular, there's a good chance that all of that pattern, all of that learning might have to be thrown out. So it's not that you can have this model and last forever. Even if it's learning, at some point there might be a change that completely changes how the application works, and it's better to start with a new model and start learning again. So do be careful for that. And so tools that would do this, they can understand IDs because you're seeing IDs over time. So you'll know which numbers change, which numbers don't change. If I open up an invoice 20 times and the IDs on these elements is the same, then I can probably deduce this is the invoice ID. If I load the invoice 20 times and the number changes, it's not the invoice ID, it's a session ID. It's useless. So things like numbers take on meaning depending on what happens 20 times of loading the page. The number itself isn't necessarily good or bad. It could be good, it could be bad, depends on change. Same thing with attributes, same thing with classes. Understanding if you reload the page hundreds of times, do the classes change or are they consistent? So what does machine learning bring to the table? Well, it can scan the application and it can scan it lots of different times every time the page is loaded and many different users, and it can understand which ways of finding elements is consistent and which ways is not. And it can then build a model for finding these elements. And then what it can do is make what we call self-healing locators. A self-healing locator is a way to find a button on the page that is consistently reliable, even though the page loads 100 times and they're on different invoices or different user profiles, it still works. And also, if the application changes, it can even still find that button depending on how much of the application has changed. Obviously, if it's a complete redo, it might not. But if there's simple changes, it won't break immediately like our current technologies tend to do. So how does it work? Well, how do these tools kind of work? Well, what they'll do is they get the attributes and they try and sort them to find out what's unique on the page. And a computer can do this much better than we can. So let's let a computer do that. We can then get the same document multiple times and compare them. We can also open up 100 invoices, go through every single line in a grid, click on it, open it up, look at all the 100 line items, which are the same page, but with different data, and understand what's the same, what's different, and do large-scale comparisons. Okay, do all that. That's great. And then we can use that to identify which attributes on this application are useful, which ones are not, which ones are being used in lots of places, which ones can we throw away. And it can build a model like this, which looks at the frequency of the attributes, looks also at the reliability of the attributes, of the correlation, and finds out for my application that I'm testing, what's powerful, what's useful, what's useless. And then the system will then build anchors of items that it can find. And what it will do is it will automatically determine that this button role menu item is useful and this customer's label is useful, and it will discard other things that it finds less useful. And it will automatically know that because we have 10 layers with the same IDs and same values, that we need to add this position on. So again, a computer can do this really easily. It can scan a document much faster than we can, and it can understand, what's the first layer, what's the last layer, or there's only one layer and we don't need this. It can scan and find the same attribute 10 times, but 9 of them have got visibility equals hidden. The computers are really good at that. As humans, that's not something we should be doing by looking at, a giant page of XML. We should be using computers to do that for us. So what's the end goal? Well, the end goal is what we call a self-healing test, where it looks at a particular object and it does this. It analyzes all the different ways of locating it, and it basically says, okay, based on what we found, the probability of that being the same thing is 94%. If you look, this is what we had, username with a space, and we've now moved to username without a space. A traditional automation framework will fail. It will say there's not a 100% match, and it will fail. A self-healing technology would say, oh, that's a 94% match. And here's the really important thing, though. When you run these tools in self-healing modes and you use a self-healing kind of framework, one of the most important things is user feedback. Because if I look at this and say, you're wrong, that is different. That's a fail. It's not the same thing, because that's meant to say username with a space. I give feedback to the tool that it's not the same, and the model will learn from that. So that's the other really important part, is when you run the tests, there's I think a tendency towards thinking that I run the test, I record the test, build the test, play the test, and it passes or fails. With this self-healing and machine learning approach, that's not the way it's going to be. It's going to be you record the test, build the test out, play it, and you then get a set of suggested passes and fails. And you as a human person will go through the application, review all of the machine results, and you will give feedback. And eventually you are training the model so that the next time you play the test, pretending what you told it in this case, it's going to know that is actually a pass or a fail. So going back to the idea of what is manual testing, what is automated testing, that goes away. It's not like the machines are running on their own and doing things. What's happening is the automation is doing all the hard work of comparing documents, looking at XML, looking at DOM trees, all that stuff. We as humans are reviewing the results, giving feedback to improve the model, rather than us trying to build a machine ourselves in a framework that's going to be completely, perfect every time. That's very difficult for us to do. It's much better for a machine to do that and us to give it feedback. That's what we're good at. We can see right away that is the same or not the same. We know the business context. We know, were we testing for spelling? Were we testing for a label? Depending on what we're testing for, that could be a fast pass, that could be a fail. We know the business, we know the user interface, we know what's supposed to be the case. We give feedback to the tool, and the tool improves. And what that does behind the scenes is you get something like this. This is how we're tracking it in our frameworks. It's a JSON model that's basically a model of the application. And as the application is being automatically tested repeatedly multiple times, the application is building this profile where it actually knows which parts of this application are good, which elements to avoid. Do we need to have different layers? Do we ignore certain things? Like, for example, we can use hrefs, but we should ignore JavaScript. We can use IDs, but we shouldn't use ones that have numbers in. The system builds this profile out. Do we need to automatically append a position last onto things? So this is a framework profile that's being built by the machine based on what it's learned, so that when we play this test the next time, we don't have to go through all this aggravation. The system knows what's useful, what should we discard, and then your test won't be flaky. But this model is specific to the application. You can't take this model for, say, Salesforce and say, oh, let's use it on Google. It won't work. You've got to build a new model. So you're going to have these different profiles for each of your types of application that you're testing. And this profile becomes effectively the framework. That's the intellectual property for testing your application. So just to wrap up and allow time for questions, the Moz500, the 500 most important websites in the world, the research project showed us why automation is hard, particularly why automation of websites is hard. And we also did a look at why the current technology. And current technology, I mean being able to use tools like Selenium or even automated commercial tools, things that are based on using specific fixed locators for elements, IDs, all that stuff. That just doesn't work. CSS and XPath in the current way we use it is not helpful. It's unstable, it's brittle, and the modern frameworks we're using like React and Angular and other frameworks are making it harder and harder. And that the future is going to be self-healing tests and intelligent machine-driven object identification coupled with human feedback to improve the model. That's where we're going. That's what automation is going to look like. And with that, I'm going to move us into questions. So let me close my presentation and stop my screen. And I'm going over to the questions. So if you want to write your questions into the Slido, I'll be ready. Here we go. So as you write your questions, it takes a while for the questions to catch up. Just some thoughts about this. It was interesting. One of the things that my colleagues who did the research project found that was very interesting was they were watching someone do. The reason why we did this is we were looking at someone, a client of ours, do test automation, and what we found was that the person was behaving like a robot. So as a manual tester, what you're doing is doing what humans do, right? I go to the application that I'm going to test. I bring up the screen, and I click through the application as a user, and I see the application is good, and I see that the layout looks good, the menu is working, and I see there's a misspelling. I see something else. So what I found when you look at a human doing test automation, we're making people like robots. People are going to like the browser, doing F12, they're going to the DOM tree, they're copying the XPath or the CSS, they're opening up Selenium code, they're pasting it in. We are literally training humans to be computers. Instead of when we're doing manual testing, we are being humans acting like humans. So that's where the idea came from, is let's make the computers, let's make the automation tools do all the pattern matching, all the recognition, all the XPath, all the hard stuff, all the stuff that's really good for computers to do. You know, large data scale analysis is what computers are built for. Let's have humans do what humans are best at, reviewing the results, giving feedback, and improving the model. Okay, we have some questions. Could you mention exact tools for machine learning algorithms performing? Okay, now this is a non-commercial talk, so I don't generally talk about the tools. The tool that we have, that we write, is called Ripise, R-I-P-I-S-E. That's our tool. And I think in terms of machine learning, we need to be really careful here. We're still at the beginning of our journey. So our tool Ripise is called it's our automation tool, and it's using self-healing locators, and it's in the beginning of this journey of automation. So right now it can do some of the things you saw we can do already. In fact, some of those screenshots came from our tool. I took the name off because, again, this is not meant to be a vendor talk, so it's really more about the process. Other vendors are doing the same thing, so definitely look at our tool, look at other tools. Doesn't have to be a tool, though. Some of these techniques could be done completely open source as well, because a lot of this is not even just machine learning. A lot of it could be done just programmatically. So what happens is, if you go to a web page, any tool that can spider the DOM and can read the DOM, you just have to capture that DOM and use diff tools. You could do a diff tool, look at the web page 50 times, load up the same page 50 times, and do some of the analysis. You can build a framework or your own JSON model where you could describe which attributes are useful, which are not. Be careful with machine learning and AI, though, because a lot of tools say they can do all this stuff and they can't yet. the industry is definitely moving in this direction. In 5 years' time, I think every automation tool, certainly a commercial tool, is going to have to be machine learning based. It's going to have self-healing locators. That's just going to have to be the functionality. It's going to be what every tool will need, or you won't be able to compete. What some tools are doing is they're using machine learning to do page speeds. So there are some tools that use AI to be able to look at the speed of a page loading to make it dynamic. There are some other automation tools. I'll mention one, Appler Tools, which is another tool out there. They do a lot of work on image recognition. So they can see the application and they can basically see the picture, and they're doing pattern learning on the images. So there's different kinds of automation in AI. So it depends on the needs you have. The one that we have is basically taking effectively XPath and CSS locators, mostly XPath actually, and we're doing that, and we're automatically scanning the pages and generating these profiles and then building XPath dynamically based on that, using multiple XPaths per element. So that's what we do, but there's not just one approach. So I don't want to spend much time on our tool. That's not the point of it. How do you think the tools will handle sites that are intent to avoid robot crawlers? Avoid robot crawlers. Well, I guess there's two parts to that. A website has a robot.txt file which tells someone like Google, a public crawler, that you should or shouldn't crawl the site. Now, Google doesn't have to follow that. Now, Google does follow it because that's the point. But so when you say prevents crawling, if you as an automation engineer are automating an application, I would hope you have permission from the person to do that. So you don't certainly have to be bound by the automation, by the robot.txt file. You could go ahead and automate it. So I don't think when you say intent to avoid, the robot.txt file shouldn't be an impediment because you are doing it for a very different reason. Now, if they've got some code or things to do in the XPath, in the DOM, in the web page to break it so that it's really hard to spy to the application, that's going to make it more difficult for sure. Now our tool is designed that a human can actually still record the application, and when you do the playback, it captures it during the playback. So tools that are designed to have a human direct you through the application, those would still be okay. If it's also going to be a tool that goes to every single page in a spider form, that's going to be more difficult if they've got things in there to try and prevent you indexing all the pages. So sometimes people do that from a security standpoint as well. So it depends a little bit on what kind of way you're going to capture. We let you have a user walk through the application as if you were recording a test normally, and we're capturing lots of things. So that's what we do. But if you are spidering it, then obviously some things will make that more difficult. So is there an open source project tool with self-healing like Selenium? Our tool is not open source. It does integrate with Selenium, so you certainly could do that. There are other commercial tools that do some degree of self-healing. They can be integrated with Selenium for playback through WebDriver. Open source, I must admit, I don't know of any. Not offhand. I haven't. We're a tool vendor, so we probably wouldn't be the best people to ask. I don't know of them. Let me have a look here. AI testing. Any tool, software platform for AI testing. AI testing means a lot of things, so it depends what you're testing. If you're doing testing of web apps and you want to have AI helping you, something like ours is good. If you're doing a graphic, a search of a website that's all images and you want to be able to find things on there, something like Appler Tools is pretty good. If you're looking for something that's doing data set analysis, looking at large data, there are some AI tools that aren't looking at UI at all. They're looking at how you can search a giant data set and find patterns. So that's a different kind of testing. And there are different tools that do that as well. Is there a solution for errors like element is not attached to the page document? So this is the case where you've got like a div and it's not attached to the DOM yet. And this is not really directly to do with AI or anything. Let's say it's something like React. There are things like, I believe, Protractor. There are tools where you could test the framework before it renders the DOM, so that way you could find objects that aren't yet rendered into the DOM. If anything that's looking in through the web browsers will only find things that are attached to the DOM, because the browser won't let you access them otherwise. So you can't go /document/body. So traditional XPath, anything that's running in through like Selenium or WebDriver, typically can't find it. But if you're using a specific framework, you could use that to test like the shadow DOM. Like I think it's React has a shadow DOM. You could have something that's running at the JavaScript layer, like something like Jasmine, have some code that's testing the shadow DOM before it's rendered. So There are ways of doing that. It's not exactly the same thing, but there are ways of doing that. But it's a different approach. The problem there would be that's a whole different set of testing you have to do. You're now unit testing your JavaScript generation framework before the DOM is rendering it, and that's a totally good thing to do. But it is a whole different level of testing you're going to have to do. But you might find that's really worthwhile. If this is something that happens a lot, then it's worth doing. Like a lot of things, you have to look at the time taken to invest in doing that versus the time you're saving. If you come across the element not attached once in a blue moon, maybe it's better just to simply accept that failure and move on. If it's something that's happening all the time for you, then invest in something that can actually look at the JavaScript and look at the DOM before it's rendered, injecting it into the web page itself, into the web framework itself, I should say. So that would be a good option. Let's have a look here. I think that's all the questions so far. So yes, if you have any other questions, come to the Ask Me Anything corner. I appreciate the opportunity to speak today. Thank you, TestCon. Thank you, everyone, for attending. Have a great rest of the conference. And for myself and everyone in the Washington, D.C. area, I hope you're having a great afternoon there. And I hope you see you at a future event and hopefully next year in person, or if not online. It's been great. Thank you.